Greetings, West Springfield High School geometry students. This video we are going to be talking about topic 18, which is the Pythagorean Theorem. And the first video that we're going to do on this topic is going to include a couple pieces of essential knowledge that are going to be sort of the foundation of the work that we're going to do on the Pythagorean Theorem. The first thing that we want to talk about here is something we've touched on a little bit so far during the unit, but talking about the parts of a right triangle, okay? The longest side of a right triangle is called the hypotenuse, and that is the side opposite the right angle, okay? You can see it's on the other side of the triangle from the right angle. When it comes to the Pythagorean theorem, that is the side that we absolutely have to identify correctly. If we do not, then everything that we do with the Pythagorean theorem is going to be inaccurate, and you will see what I'm talking about, I think, in a little while here. The next thing we are going to talk about is the Pythagorean theorem itself. Okay, the Pythagorean theorem is a squared plus b squared equals c squared. And remember, what I said is that it's important for us to correctly identify the hypotenuse, the longest side, okay? If we have the hypotenuse incorrect, then everything we do with this formula is going to be off, okay? So one of the first things we have to do when we are working with the Pythagorean theorem is we have to correctly identify the hypotenuse and make sure that it is the c portion of our equation, okay? The two legs that we have, it doesn't matter which leg we make A and which leg we make B, as long as our hypotenuse is C. And finally, Pythagorean triples, okay? Pythagorean triples are sets of three whole numbers which could be the measurements of sides of a right triangle. How do we know when we are dealing with Pythagorean triples? We will know when we're dealing with Pythagorean triples if the numbers that are part of them satisfy the Pythagorean theorem, or a squared plus b squared equals c squared. And again, the longest side must be the hypotenuse. So if you look here at these examples, I've got some examples of Pythagorean triples over here, and then I've done mathematically an example right here of a Pythagorean triple with 3, 4, and 5. Okay, remember, 5 is the longest side of our triangle here, so that is going to be our hypotenuse, which means we have to set 5 as C, or C as 5, okay? The other two legs we can plug in either place, but the hypotenuse absolutely has to be C. And if we plug all these values in here, we see that 3 squared plus 4 squared, and we want to know if it does equal 5 squared. 3 squared gives us 9, 4 squared gives us 16, and then 5 squared gives us 25. 9 plus 16 gives us 25, and because these are equal, this would be a Pythagorean triple because it does satisfy the Pythagorean theorem. Okay? The next two videos in the series that we're going to be doing here are going to be elaborating a little bit more on topics 18a and b, being the applications of the Pythagorean theorem and the converse of the Pythagorean theorem.